Good afternoon, everyone. Welcome to the last week of this course on the joy of computing using Python. I hope all of you have been enjoying up until now, and hopefully, you will continue your programming journey in the future. And this was just an overview, a glimpse into the world of programming for all of you. So, for most of you, I believe this would have been the very first course that you have ever taken in programming or in Python programming language. So, I believe that by now you have got a pretty decent idea of how to write simple programs in Python, how to use different libraries and packages, how to you make use of the built-in functions, and how to write your own functions and things like that. So this is the last week, week 12. This is the concluding week. And today will be, this week will be the last week of your course. Next week, we would have like a revision session. So today we will solve some of the previous year's assignment questions from week 12, assignment 12, quiz 12. And next week, what we will do is we will do some revision so that you are a little bit more prepared before entering the exam. So yeah, today is the concluding session. Next week would be just a summary or revision kind of a session. So before proceeding, let me just share the link to the YouTube channel for those of you who are joining for the first time. So this is the link to the YouTube channel, and if you are joining for the first time, then you can go to that channel and you can watch videos from previous weeks as well. All these programming problem solving sessions are live streamed on YouTube and they are available on YouTube forever. So if you happen to have missed any session, then you can just go to the YouTube channel and watch the session over there. Okay, with that being said, let us get started with the assignment questions. So this week was basically a follow-up on last week. So last week we were introduced to the topic of networks and how networks and graphs work in Python. This week we have done some applications of that networks package. So we have seen how page rank works, how page ranking works, and how websites and search engines, how they use these page rank algorithms to basically sort pages in the order of increasing or decreasing popularity. So that was the aim for this week of using applications of that networks package. So let us start with the very first question. Ranjini K, could you, it seems you have some query. Could you please unmute and ask? Ranjini, are you there? I don't think I understood your query. You have written ma'am screen. Am I am I audible to all of you? If you could just give a thumbs up reaction or something.
Yes, madam.
Okay, and is the screen visible?
Yes, yes.
Okay, so if someone is facing some issue regarding the visibility of the screen or things not being audible or stuff like that, then I suggest going and watching on the YouTube channel because sometimes I have seen that Zoom does some funny things to the connectivity. As a result of that, sometimes the quality degrades. So I would suggest that if you are facing any issues, then you can go to YouTube. So Ranjani, if you are facing some issues, then you can try watching it on YouTube. Okay, so let us start with the questions now. Let me start the poll. First is a true false type question. So I have lodged the poll. The first question is, the number of people referring a person matters more than who is referring the person. Is this true or is this false? So it would be nice if all of you can attempt to solve this question, means basically answer this poll. Okay, let me stop the poll and share the results with all of you. So it has been 50-50. But the correct answer is false. See, if more influential people refer a person, then that holds more value than having a whole bunch of less influential people referring a person. So, both these aspects are important, but definitely uh, it matters more when an influential person is referring a person or a more important person refers as opposed to many not so important people. So this is the fundamental key idea behind page rank algorithms. So that's why this is the first question. Next question. Which of the following is true about page rank? So we have some options. Let me launch the poll. Okay, so which of the following is true about page rank? This is about websites and hyperlinks and whether they are nodes or whether they are edges. So we were introduced the concept of graphs in last week where we saw what nodes and edges are. So in that context, we want to see whether websites and hyperlinks, whether they are nodes or edges.
The options are not available. The question is not available to see.
Sorry, you are not able to see the question?
That's the question.
Can you see the question now?
That fourth page overlap.
Sorry, what are you saying?
Page on your code is overlapping that question page.
Are people not able to see the question?
Question is behind that page of poll.
Is it better now?
No, it is completely behind of that poll page.
Could someone write in the chat box if they are able to see the question or not?
That poll page can't be shared separately after reading that question.
Uh, uh, could you just give me a minute? If someone is, could someone just type in the chat box what they are seeing? So, so people are able to see the screen as well as the poll. Could you just minimize your poll window that is at your end? This is not at my end.
The page has the option of closing only, not minimizing option is not there.
Are you on a computer or a mobile phone?
Computer.
So there would be this option of minimizing the poll window. Uh, if someone else knows the solution to this, could someone just uh, type in the chat box the solution to the problem? Someone is not able to minimize the poll window, so if people can help him out.
I have clicked on that poll tab. Now it has disappeared now. I can see the question now.
Okay. And then
But
I
that
think you can click back and answer.
okay.
Okay. And if you are facing issues, then you can go to YouTube and see it
Okay.
in YouTube.
Okay, thank you.
Okay, so people please take some time to answer. Okay, so let me stop the poll now. Okay, so the correct answer to this is option A, as most of you have selected. Option A, websites are nodes and hyperlinks in websites are edges. And how this is the case is, let's say you land up at some website. So, and then in website, you will have different options, different buttons, different things, different clickable items and images. And basically, when you click on them, they will lead you to a different page, different landing page. So basically, when you click on a hyperlink, that is like a directed edge. So clicking on a hyperlink is like directed edge. You are going from that start point to the end point. That is why hyperlinks in websites are edges and websites are the nodes. So through websites accessing the edges, you can go to different hyperlinks. Okay, so let's move on. The next question, what is a drunkard's walk? So this is also in connection with the page rank algorithm. So we saw two page rank algorithms. One was the drunkard's walk. The other one was points distribution method. So these were the two algorithms we saw for page ranking. So this one is on drunkard's walk. What is a drunkard's walk? Okay, so let me stop the poll now. So most of you answered it correctly. Drunkard's walk is random walking. Some people answered strategized walking. I don't even understand how strategized walking can classify as drunkard's walk. Some people selected zigzag walking. That still makes some sense to select that, but anyway. So drunkard's walk is random walking. Random means randomly we will pick one node and randomly we will pick one outgoing edge. So this random process of selecting a node and the edge is called drunkard's walk. So for example, let's say we have, let's draw some graph. Let's say we have some nodes. Let's say we have these 5 nodes and let's draw some edges. So let's say I randomly select one node. So let's say this node, and this has 2 edges connected to it. And then randomly I will select one edge. So let's say this edge. So this way, if we keep going, then it is a drunkard's walk. Then when I come to this node, uh, then randomly I'll select the edge. So let's say here, then I come to this node, I can go right or left. So let's say I go left. So this random way of selecting a node and the edge is known as drunkard's walk. Okay, moving on to the next question. Given a set of networks, which node in that network is considered as most impressive? So this is the idea for PageRank algorithm. This is the basic idea. And this is similar to the first question that we had about number of people referring a person versus some influential person referring a person. So that similar idea is over here, which is used to select the most impressive node or the highest priority node. So all of you, please try to select the option. Okay, so let me stop the poll. Most of you selected the correct option. The correct option is node with maximum visits. So note that amongst some people get confused in options A and B. So node with maximum incoming visits is like a large number of people referring a person. But node with maximum visits, that means that more influential people are referring a person. So this is, so that is why the first question, true false question in today's session is important. So this is the analogy. So maximum incoming edges would mean large number of ordinary people referring to a person, and maximum visits would mean that more influential people are referring. As a result, it is getting maximum visits. Okay, next question also on graphs. This one is having a graph structure, and we need to predict the output for g dot out edges 8 for the following graph G. So this graph that is drawn is called G, and we need to say what the output of this line would be. So everyone please think about it and answer the poll. Okay, so let me stop the poll. The correct answer is option A. So let us look at it. So G dot out edges 8. This means we need to look at the node 8. So this is the node now which has the number 8. And if you see, it has got only incoming edges. See, all these edges are incoming. So this particular node has 3 incoming edges, but 0 outgoing edges. And G dot out edges will basically tell you. So let's say if I have G dot out underscore degree, and then we have node number over here, node number. So this basically tells you number of outgoing edges. If instead of out we had written in, that would tell you number of incoming edges. So that's how this function out degree works. Moving on to the next question. Which of the following is true about undirected graph? So undirected graph is basically graphs in which edges do not have any specified direction to them. So let me relaunch the poll. So everyone please try to answer. Okay, let me stop the poll. The correct option is option 1. One can come back and forth from one node to another using a single edge. That is for undirected graph. Okay. And the second option, this one, is for directed graphs. Okay. This option is for directed graphs. In directed graphs, you can only move in the direction of the edge. So every edge has a specified direction, and if that direction is given, it will move. You can move only in that direction. So okay, so we can move forward. Okay, before that, one can this third option is true for a complete graph. So in a complete graph, which is of course undirected. So in complete graphs, all the nodes are connected to all the other nodes. Okay, that is what is a complete graph. Okay, someone is saying some things in the chat. Ranjani is not able to see the screen. Are other students able to see the screen? If people could just respond in the chat box. Just write yes if you can see the screen, or...
Yes, we can see the screen.
Okay, Ranjani, what is the issue? Could you just unmute yourself? If you are there, Ranjani. Okay, fine. So anyway, Ranjani, if you still face the issue, then as Janvi had asked for it, I have provided the link to the YouTube channel. You can go and watch on the YouTube channel as well. So, okay, yeah, coming back to this question. So, this third option is for complete undirected graph. So, complete graph means every node is connected to every other node, and you can go from one node to the other through any edge. Okay, next question. Which of the following statements will choose a random node from graph A? So any graph will have a certain number of nodes, and we want to choose a node randomly from that graph. This is for, let's say, if you want to implement any of the page rank algorithms. Okay, so let me stop the poll. The correct option is option C. Random.choice a.nodes. So name of the graph is A. So a.nodes will give you the list of all nodes. and then random dot choice will select one element randomly from that list. And all of you know, to use the random functionality, you need to import this library package called random by import random. Okay, next question. Which of the following is not true about Collat's conjecture? So in this week, we also saw in the last few videos, I think last two videos, what the Collat's conjecture is. And so we have a few questions on Collat's conjecture as well. So everyone, please try to attempt the poll. I hope all of you have watched the video on Collat's conjecture. Oh, it seems people have not watched the videos on Collat's conjecture. Okay, let me explain. So, for those of you who have not watched the videos, so this is week 12, last two videos. Last 2 or 3 videos are there on Collat's conjecture. So if you watch those, then you will know what Collat's conjecture is. But if you don't know, I'll just briefly explain it to you. So in Collat's conjecture, we start with some integer, positive integer, so to say. So some whole number. We start with some whole number. Okay. And if, let's say, whole number n, if it is even, then what we do is we divide this number by 2, and if it is odd, then we multiply it by 3 and then add 1. And this is how we keep on updating the number, and we keep on repeating this process over and over and over again. Okay, so this is the Collat's conjecture, and the conjecture is that if you do this thing over and over again, then you will reach the number 1. If you keep applying this process over and over again, then after a few steps, and there is no pattern as to how many number of steps it will take to reach the number 1, but it will reach the number 1 after some steps. Basically, it will reach this convergence to this number after certain number of steps. This is the Collat's conjecture. So no matter what positive number, positive integer, whole number that you take, if you keep on applying these steps, then you will at some point of time reach the number 1. So okay, now that I have discussed, and it may keep on cycling also. So in the videos you would have seen that it goes 4 2 1 4 2 1 4 2 1. This way it keeps cycling once it hits 1. But yeah, that's the Collat's conjecture. So the correct option is for this question, sorry, this was supposed to be a multiple choice correct question. I started single option correct, but I'm really sorry about that. So the correct options, there are two options which are correct. Option A and option C. So bigger the number, larger the number of steps, it will take to converge. This is not true. So in the videos we saw that number 7 took not many more steps to convert, whereas the number 256 took very few steps to converge. So that is not the thing. And it may or may not converge, but it's like there is no proof that it will converge. That is why it is a conjecture. So you cannot prove that this will converge, and you cannot prove as to how many steps it will take to converge. That's why it's a conjecture. So in mathematics, when something is called a conjecture, that means that there is no proof to it. It's just that it has been tried some 100 times, 1,000 times, 10,000 times, and stuff like that. And it has been seen that it happens to be true, but there is no formal, rigorous mathematical proof to show that this something would be true. So that's when you call something a conjecture. And when you have a proof, a hardcore rigorous proof for something, then you call that a theorem. So that's between conjecture and theorem. Okay, next question. In Collat's conjecture, if a number is even, then what should be the next step? So I just discussed this now. So I believe everyone should get this one right. So I just explained what Collat's conjecture does. Okay, let me stop the poll now. So the correct option is option A. I had just now discussed what we do. So if the number is even, we divide the number by 2. If the number is odd, we multiply it by 3 and add 1. So this option C is for odd numbers. And then we keep on repeating this process until we reach the convergence to 1. Okay. Next question on Collat's conjecture. So we start with the number 10 and then we apply this process of checking whether it is even or odd and then applying the corresponding arithmetic operation on it. And then we will see how this number 10 converges to 1. So we want to find out what the convergence sequence for the number 10 is. Okay, let me stop the poll now. So the correct option is, all of you selected correctly, it's option A. So let's see how. So we start with the number 10 and this is even. So because it is even, what we do, we divide by 2. Then we get 5. 10 divided by 2 is 5. Now 5 is odd. Then what we do is we do into 3 plus 1. So 5 into 3 is 15 plus 1, that's 16. Then 16 is even. So what do? We divide by 2. We get 8. 8 is again even. So what do? We will divide by 2. We will get 4. 4 is even. Sorry. Again we'll divide by 2. We'll get 2. 2 is even. Then what we do? We divide by 2. And then finally we will reach 1. So this is the sequence: 10, 5, 16, 8, 4, 2, and then 1. Next question is again on graphs and nodes. So what is a sink? This is in connection with graphs and networks. So everyone please try to attempt the poll. Okay, so let me discuss the answer. So the correct answer is option D. A sink is a node with no outgoing edges. And option A will be for a source. So what does a sink mean? It means you have a node and all the edges point inwards to it. It has only incoming edges, no outgoing edges. So this is what is known as a sink. Next question. What do we do when encountered a sink in the page ranking algorithm? So now that we know what a sink is, so in page ranking algorithm, what we do is, as I had demonstrated earlier, see over here, as I had shown, what we do is we randomly select a node and then we randomly select one outgoing edge and then we move along it and keep on moving by randomly selecting the nodes and edges. But what will happen if we reach a node which has no outgoing edge? That means a node which is a sink. What do we do then? It has got no outgoing edges. So there is no chance of randomly selecting one outgoing edge and following that path. So this question is on that. Okay, let me stop the poll. So the correct option is option, oh sorry, let me change the color. is option C. We will randomly choose a node from all nodes. Some people selected option D. They said randomly choose a node from neighbor nodes. No, that is not correct. The correct option is that we will randomly choose a node from the list of all nodes that are available to us. Next question again on page rank algorithm. In the page rank algorithm, we need to select which of these options are correct. Okay, let me stop the poll now. So the correct option is option D, that both options B and C are correct. So this is also correct. This is also correct. That's why both B and C are correct. So this is for the drunkard's walk method of page ranking. Let's move ahead. Which is the following graph? So this particular shape of the graph is there. You have to select what this particular shape or type of graph is called. All of you, please try to attempt. Okay, so let me stop the poll. Correct option is option C. This particular shape is called a barbell graph. And how do we generate this graph? So the code segment for that is as follows. So first of all, we would have to import the networks library. Then to plot it, we also need to import the matplotlib library. And then we will draw this graph. We will initiate this graph. We will draw it and then we will display it. So this is the code snippet for generating this graph. Notice these numbers over here. So what do they mean? They mean that, see, at the end of this graph, we have this connection of three nodes. So this 3 in that argument means these three nodes, and what they do is they form a complete graph amongst themselves, meaning all these three nodes are connected to each other. And then the second argument is 4, and that is this part, the number of interconnecting nodes between these two ends. So why it's called a barbell? Well, if you people go to gym, you would have seen that there are these barbells for weight training. So what you have is, or if you have ever seen Olympic weightlifting, then there are these rods and then weights at the end of it. And then what the Olympic weightlifter does is that he or she comes and basically lifts this up. So then, pardon my drawing, it's a little bit out of proportion, but this is the idea. So this is what is called a barbell. So this shape is somewhat similar to this network graph shape. That's why this one is called a barbell graph. So let us try and run this in Python and see that we indeed generate this kind of a graph. So let's go to Spider. Okay, so this is the Spider console. Let me import my package. Then we will initialize our graph. Okay, so let us run this. See, this graph is there. It is just plotted in a slightly rotated manner, like tilted 45 degrees, so to say. But that orientation does not matter. What is important is this shape. So you see that there are three nodes at the end, which form a complete graph. Three nodes at this end as well. Three nodes at both the ends. And then there are these four interconnecting nodes in between. So this is a how you make a barbell graph. Okay, let's come back. Okay, so someone in the chat box is asking me to run the code again. So fine, let me do it once again. Let me go back to Spider. So someone just wanted to run it again. So see, I just ran it again. Again, the orientation is not important in any network kind of a graph. What is important is the ordering and the sequence of the nodes and the connections of the edges. So that is important. So someone just wanted to run again, so I just ran it again and I showed you. So this is how it looks. Okay, let's come back. Moving on to the next question. Which of the following is a star graph of node 5? Okay, so let me stop the poll. As the name suggests, a star graph will look like a star, and the correct option is option A. This is the one which is a star graph. And how do we generate that? The command for that is g equals nx dot star underscore graph, and then we will provide the number of nodes, which is 5. So number of nodes meaning apart from the center, how many connections are there? So you see there are 5 connections apart from the central node. So that is why this number 5 is there. And the other options out here, so this one right here is a complete graph. This is a complete graph. And this one over here is called a wheel graph. So the codes for generating complete graph is nx dot complete graph and then the number of nodes, which is 5. And for wheel graph, you have nx dot wheel underscore graph and number of nodes, which is 5. So these are the other types of graphs that are there. Again, let me just quickly demonstrate it in Python. So instead of this barbell graph, we will now have, let's say, complete graph. And this takes only one argument. Okay, first let me show it the star graph to you. See, this is the star graph, exactly how we wanted to generate it. So as someone rightly pointed out in the chat box, that this star graph is having a total of 6 nodes. And that's right. It has 6 nodes, but apart from the central node, it has 5 nodes. So the way you write the code for generating a star graph is, in the argument, you pass the number of nodes excluding the central node. So basically, the argument is essentially the number of edges you can see. So star node 5, so star graph 5 is basically, you see there are 5 edges. You see over here, we have like these 5 edges. So this is star graph. Now let me show complete graph to you. See, this is the complete graph, exactly how it is there in the options in the question. And then let me show you wheel graph. See, this is the wheel graph. And why it's called a wheel? It's because it kind of looks like a wheel with spokes being connected from the center. For example, if I put wheel graph, let's say 15. Oh, sorry, this is too many nodes. See, so what it looks like? It looks like a wheel with spokes connected from the center. Okay, so let us come back. Moving forward. In the page rank algorithm, the leader is decided by, you need to figure out that at the end of the page rank algorithm, who do we select as the leader? So take a few more seconds to answer. Okay, let me end the poll. The correct option in this case is option C. Most of you selected option C. So the leader at the end of the page rank algorithm is a node or a person which is visited maximum number of times. And we have seen similar questions earlier as well. Let me show you. Yeah, here. So, node in the network which is considered most impressive, that is equivalent to saying who is the leader, and that is the node with maximum visits. This is the question which is similar to the one that we just answered. So a node which is visited maximum times is selected as the leader.
Madam, will you explain us how it is related, logic behind that? Just number of visits is related to that influential person.
Okay, so let's say we have a node and let us say it is being directed by let's say only two nodes. Okay, so we have this one node over here and then it is being directed by these two nodes. Okay, and these 2 and 3 nodes are there, and let us say what happens is, let's say 4 or let's say 5 of these nodes point to 2. So we have these 5 nodes all pointing to 2, and let's say we have 3 nodes all pointing to 3. Okay, now you see that even though the node 1 has least number of incoming edges. Not least, all these other peripheral nodes also have no incoming edge, so to say. But if you look at it, node 2 appears to be the one which has maximum number of incoming edges. But still, this is not the leader. The leader is going to be 1. And why this is going to happen is because if you apply the page rank algorithm of randomly selecting one node, so let's say I randomly select this node, then what happens? This node points to 2, I go to 2, and then 2 points to 1. So I go to 1, and then I reach node 1 one time. Let's say if I select this node over here, again same thing. This node points to 2 and then 2 further points to 1. So I visit 1 once again. What happens if I select a node over here? This one points to 3 and 3 further points to 1. So you see I am visiting the node 1 maximum number of times when I apply this page rank algorithm of randomly selecting a node and following the edges. So if I keep on randomly selecting these nodes, let's say 100 times, you will realize that majority of times you would end up at the node 1. Because all of these are at the end of the day pointing to 1. But if you look at the number of nodes which are directly pointing to 1, then that is only 2. Only 2 nodes are directly pointing to 1. So it's like only 2 people are referring to 1. But if you look at it, for node 2, there are 5 people referring to node 2. So even though more number of people are referring to node 2 and less number of people are directly referring to node 1, still node 1 emerges as the leader because these 2 and 3 nodes are influential people. Influential people meaning they bring along with them all these large number of nodes. So 2 brings with itself all these nodes, all these 5 nodes. 2 brings with itself, 3 brings with itself the support of all these 3 nodes. So it's kind of like, if you see that, kind of something like an election happening over here. So this person 1 is standing in the elections and it directly knows only 2 people, person 2 and person 3. But this person 2 brings along with himself the support of many other people. Similarly, person 3 brings with himself the support of many other people. So these are influential people. They can influence a large number of people to eventually support this person 1. So that is how this page rank algorithms work. And that is how
But,
this influencing
but
thing works.
got it, madam. Thank you.
Yeah, okay.
So I have to study a visit concept. Now I have got that idea clear. What is meant by visit?
Yes. So visits
So
means
that
how
visit
many
concept
times,
now you
yeah, how many times in that following the path do you actually hit that node? So visiting a node means you will follow the edges, keep following the edges, tracking your path, and finally reach that node.
okay. Thank you, madam.
Okay. So great. Good question. So let us move ahead. Next question. What will be the output of g.out degree 3 for the following graph G? So we have seen a similar question earlier today itself. So this is just to revise that concept of out degree. So just try to attempt this once and then I will discuss the answer. Okay, so let me stop the poll and discuss the answer. So it's kind of 50-50. 50% people selected A, 50% selected B. So this is a little bit tricky question. You have to be very focused when you are trying to answer this. So G dot out degree 3. So this 3 out here means the node number. So this is the node number 3, and out degree means number of outgoing edges. So we need to count the number of outgoing edges. So let us count that. So this one is an outgoing edge. 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 Now note that we have one edge over here which is both outgoing and ingoing. It is bidirectional. See, this one is outgoing also and incoming also. So we will count it both in outgoing and incoming. So for now, this is also an outgoing edge. So be careful with this node. Some people, I think, forgot that this edge over here is a bidirectional edge. It is both outgoing and incoming. So as a result, what we have over here, we have 5 outgoing edges and we have how many incoming? 3 incoming edges. And of them, we have one common edge which is bidirectional. Okay. Sorry, not 3 incoming edges. How many incoming? I think I counted incoming wrong. Let me count incoming also. So how many incoming edges? Let's see. We have one incoming edge and then one from this bidirectional one over here. So we have 2 incoming edges. Sorry, 2 incoming edges. And one of them is common to them, which is bidirectional. It's both outgoing and incoming. So that is, one has to be careful in the bidirectional edges. So I think some people who selected option A, they just missed out on this bidirectional part. Otherwise, had this bidirectional edge not been there, then your answer would have been correct. But for now, the answer is 5. So out degree gives you the output as the number of outgoing edges. Next question. Which of the following is true about directed graphs? Again, something similar we had seen earlier. So if I go, let's keep going. See, this is a similar question that we had seen for out degree. And somewhere I had, there was a question about, yes. So here this question was there about undirected graphs. And now this question is about directed graphs. Okay, so the correct answer to this question is option B. In directed graphs, one can only go forward from one node to another using a single edge. And some people selected option A, but option A is for undirected graphs. Going back and forth is true for undirected graphs, and directed graphs are unidirectional, one way. You can just move forward in that. Okay, so finally last MCQ type question, and then we will move on to the programming type questions. So let me start this poll for one last time. What will be the output of the following piece of code? So very simple 2-line piece of code is there. We have one word and then we are printing something. So what is the output? Okay, so let me now discuss the correct answer. The correct answer is option C. Most of you selected it. So what this list command does is it converts the given string into a list of characters. So it converts string to list of characters. And characters means all alphabets, letters, and spaces, and any kind of special characters like this exclamation mark. So characters is just everything: alphabet, number, space, punctuation, special characters. So let us run this in Python and convince ourselves. So let me get rid of all of these networks. So we have word equal to hey there, and then we are printing list of word. See, this output is a list of all the characters, H, E, Y, then space. Space is also there. Space is also a character. Then T, H, E, R, E, and exclamation mark. Exclamation mark is also a character. So it converts the string to a list of characters. So let's get back. So this completes the MCQ type questions. No more MCQ type questions for today. And now we move to the programming assignment questions. Okay, so the first question is write a program to take an integer as an input and reverse that integer. Okay, so let us first write it with a pen and paper. So as I mentioned in the very beginning, whenever you are writing any program, you should first think of the algorithm behind it, step by step method of writing the code, and try it with a piece of pen and paper, what the algorithm is going to be, how the code will look like, and then you should move to the Python spider console and write it over there. So let us do that. So what we need to do is first we need to take an input. So we will take input, and this needs to be an integer, so we need to convert it into an integer. Then let us convert it into a list of characters. So as I showed over here, this list function converts a string to a list of characters. So we have this integer input, then we will convert it into a string, and then we'll convert that string to a list of characters. And then once we have a list, we can sort the list, we can reverse the list by this built-in function l.reverse, and then we will finally print it. And when we want to print it, we don't want to print a list of characters. We want to print an integer. So how we will do that is we will convert it into an integer, and we will join all the elements in the list. Okay, so that is what we will do. So let us now try it in Spider. So let me remove this, and we need to take an integer input. Then we will convert into a list of characters. Then we will reverse it, and then we will finally print it. Okay, so let us run it. Let's enter the number 54321 and see, we get the reversed output 1 2 3 4 5. Let's run it once again. Let's enter this number and see, it prints it in the reverse order. So I had entered 16598, then the output came from reverse order 89561. So the code is working perfectly fine. Now we can move to the next question. Someone is asking a question. Do we get the recording of all session? Yes, indeed, you will get the recording of all the sessions, and it is available at this YouTube channel. So if you go to the channel and if you subscribe to the channel, you can see all the previous sessions available. Today's also, and all the previous week's sessions that are there. Everything you will find on that YouTube channel. So I hope that clarifies your query. And even now, if you want, if you're facing some technical glitches, then you can go to the YouTube channel and watch the live streaming on the YouTube channel. Okay, so let us proceed. Next question. Very short questions are there. So given a list of strings, write a program to sort the list on the basis of last character of each string. So typically when we are sorting, we sort alphabetically based on the first character. Okay, we sort A, B, C, D based on the first character. This time they are asking us to sort based on the last character. So that's what the given example input is there. Hardik, Rohan and Sam. So if you see, Hardik, Rohan and Sam are sorted alphabetically based on the first character. But if we sort based on the last character, Then if we look at the last character, so last character is K, then for Hardik, N for Rohan, and M for Sam. So sorting K, N, and M would give us K, M, and N. That's why the output is Hardik, Sam, and then Rohan. Okay. So this is what we want to achieve. So let us write the code. So first we will take a list of strings as input. So this is how we take a list of strings as input from the user. Then we will reverse each string. So this is how we will reverse each string. This is to reverse. Then we will sort the string. And then we will reverse it once again. And finally, we will print it. Okay. So this is the piece of code. So what I'm doing is I'm reversing each string over here. So reversing means Hardik would go to K-I-D-R-A-H. It will go to this. And then finally, then what we will do is we will sort based on this first character now, because the last character will become the first character when we reverse the string. So then that's why then we will apply this sorting, and then we will reverse again. So now this Kidra will go back to Hardik. Okay, so let us write it in Spider. Okay, so let me go to Spider. So someone had a suggestion for running in the last question. Let me put that as thing. So someone wanted to enter the number. Let me copy it from the chat box. Someone wanted to enter 52400. Okay, so let me run that. 52400. Someone wanted to enter this. So it's, oh sorry, what is happening? My computer is stuck. Enter. So see, what is happening here is when we are doing this convert to an integer. So let me show you over here. So you would have expected, let's say 00425, but 00425 is same thing as 425 when you do mathematics. So what happens is when you do int 00425, oh sorry, this is not the thing. If you, let's say a is equal to 00425, if you do this, okay, see it already gives you this statement saying that leading zeros are not permitted. So what this leading zeros are there when you have in this string dot join thing, then it is basically going to ignore that. And how that is happening, I can show it to you when we print at each step. So let's say I print a here. then I'll print L here, and then I'll print L here again, and then you see what happens. Okay, 52400. So see, we entered this input. So first it is showing what we entered as the input. Then it converts it into a list of characters. Then it reverses those list of characters. Okay. And then it merges all these characters to give you an integer. And if I did not write this int over here, then you would see 00425. Then you would not see 425. You will see those zeros also. So 52400. See, now you see this 00425 as well. And only when I had that int written over there, did it convert it into an integer and put it as 425. So I hope your query is cleared now. So, okay, so and you can use any approach that you want to write a piece of code. It's not that the method that I have given is the only way of doing things. You can have different ways of doing things. What is important is that the final output should be what we want. But there can be different ways of achieving that output. Okay, let's come back to our question. Okay, so this is the code. Let us run it and let us enter the example. Hardik, Rohan, Sam. See, it has sorted in the desired way that you wanted, and the output is the desired output: Hardik, Sam, and Rohan. So that means this is working perfectly fine. Okay, so this is done. Now we can move to the last question. So I hope this was clear and nobody has any question in this. Okay, someone wants some other inputs. So let's go back to our Python once again. Oh, someone is giving an option Mahesh, Suresh, Nilesh. Now the thing is, Mahesh, Suresh, Nilesh, all of them have the same ending. So then it will not do anything. It will just retain it. So if I enter Mahesh, Suresh, Nilesh, Mahesh, Suresh, Nilesh. Okay. So now what is happening? See, we want let's see what this code is doing. See, this is reversing so that we can have access to the last character, and then it will sort. So if the last character is same, it will look at the second last character, which also is the same in this case. Then it will look at the third last character, which is also same, and then the difference arises in the fourth last character. So that is where the difference will arise. So see, we entered Mahesh, Suresh, Nilesh. The output is Mahesh, Nilesh, Suresh. Why? Because if we move from the back, then ESH is common in all three. But Mahesh has H, which definitely comes first. Nilesh has L, which comes second. And Suresh has R, which comes third. So it is looking at the last character, but if that is same, it will look at the second last character. If even that is same, it will look at the third last character, and so on and so forth. Just like we do dictionary, like alphabetical sorting in any dictionary. If you look at, let's say, Oxford Advanced Learners Dictionary, so dictionaries are sorted alphabetically. So if the first character is same, then we look at the second character. If that is same, we look at the third character. Similarly, this is doing, but in the reverse order. It starts from the last character. Okay, so I have answered that question. So let's come back to our very final last question. Given a student's roll number in the following format, roll number @institute.edu.in, write a program to find the roll number and institute name of the student. So example input is roll@institute.edu.in and output is roll space institute. Okay, so what we will do is we will take an input and then we will split this input where this dot occurs. So the first dot occurs over here, institute.edu.in. Then roll number is what? It is basically so it for accessing roll number, we need to split at this @ and institute is this, and then we will print R and I. Now for those of you who are confused, so what is happening is we have this roll @institute.edu.in. Okay, so when we put split command, so the first split command, so this splits at this dot and it will split into two lists, one to the left of it and one to the right of it. So these are then like two separate lists that way, or rather two separate strings, you can say. So these are stored as two separate strings. You take a string input, you split it at the first full stop, then it will be stored as two separate strings. And roll number and institute both are present in this string, which is the first string. So indexing is done in Python for strings or lists or anything with the first element having index 0. And so this one will have index 1. Now we will apply another split at the @ sign. So we are applying another split at the rate sign at this point. So now what is happening is we are splitting at the rate. So it splits into two strings, one to the left, one to the right. And then roll number is at 0 index and institute is at index 1. So this is what is happening over here. I hope this is clear, and let us now write it in Python. So let's remove all of this. We will take input a equal to input, then b equals to a dot split at the full stop, then the roll number, let's split at the rate. So very simple. And let's enter roll at the rate institute.edu.in. See, the output is roll space institute, exactly what we wanted to achieve. So this brings us to the end of today's session. So let's get back to our lecture notes. Okay, so yeah, this is the end of today's session, and this was the last week of this course, week 12. And I hope all of you enjoyed the course. Personally, I enjoyed this course very much, and I really wished this would have been my first course in programming. And to anyone and everyone who comes to me asking for any programming guidance, this is the course that I suggest to them. I really feel that this is a very well made course by the instructors, and as a first introduction, it gives you uh, many flavors of Python, which is very good to have. And so yeah, that's it. Hope all of you enjoyed. And next week we will have one last session. Next week will be the revision week that we will have. So we will revise some concepts from the previous weeks so that before going to the exam, you also revise some of the essential concepts learned earlier in this course. So, okay, thank you very much. Bye bye.
Yes.
See you next
Thank
week.
you, madam. Very, very good guidance from
Th-
you.
Thank you so much for your kind words and your feedback. So it would be nice. It was very nice interacting with all of you. And for those of you who missed or who joined late or who have missed some session or something like that, I will post the link to the YouTube channel once again so that you have access to it. So yeah, that's the YouTube channel. So feel free to visit that channel and watch any of the videos that you want over there. Okay, bye bye. So some people want to connect with me in future. Some people are asking about that. So if you want to connect with me in the future, then the best way is you can post stuff on my YouTube channel. I have my YouTube channel where I keep posting things regularly. And if not on the YouTube channel, you can also connect with me on LinkedIn. So I have my LinkedIn profile. I go by the name Radhika Prasad on LinkedIn as well. Okay, so thank you very much, all of you.